Hi, this is Mark Kemper with EMS, and this is the Surphaser 75 HSX hemispherical 3D scanner. And what we're going to do today is an in-depth demo of this very unique 3D scanner. Let's start and talk about what is a hemispherical 3D scanner. Basically, the way this scanner works is it rotates in two directions. So the main body will rotate 360 degrees like you see here, and then in the middle there's another housing with a mirror in it that also rotates this direction 360 degrees. And basically the way this works is inside here is a laser source which shoots out a single laser point, and then in here is a mirror on a 45-degree angle that redirects that point straight out. And what it does is it travels out till it hits something and then sends a return back to the scanner, and inside here is a sensor. So it's basically firing one point at a time and measuring the distance, and based on where it is in location this way and this way, it can calculate the position in space as it moves around. So basically it's scanning this way and it's rotating this way, or rotating this way and then rotating this way, and it's firing out basically points like this as it moves around. And it's collecting up to 208,000 points per second. Okay? Now, what makes this scanner unique is it is a ultra short range. Okay, Surphaser makes a few different models of this type of scanner. They make a short range, which is good to about 30 feet. They make a medium range, which will go out to about 70 feet. And they make a long range, which will go out 100, 200 feet, something like that. This captures data as close as 11 inches away, which is pretty unique. Most of these other scanners won't collect data that close up. It's just too noisy. But you can get as close as 11 inches, and this will go out to about 6.5 feet. Beyond that, even if you do collect data, it's not deemed usable. So this is very specific. The accuracy of this scanner in that range is about 1/1000th of an inch, or 25 microns. So very, very accurate for this type of scanner. Weighs 11 pounds. You can see it's very small. Battery operated, integrated batteries right in here. Also has two integrated 5-megapixel color cameras, so you have the option of scanning in color if you like. So the field of view of this is 360 degrees this way. As I mentioned, it rotates this way. And even though it's rotating 360 degrees this way, you've got the base here, so we're only going to collect about 270 degrees in this direction, and thus the name hemispherical. This will scan outside. This will do up to 90 lines per degree. Now, what does that mean? So if you took 1 degree from the beginning of the scanner here, and as you project it out, that degree, that distance will get larger and larger. So think at 6.5 feet out, whatever a 1 degree distance would be, if you slice that up 90 times, that's the density of the data. So very, very dense data. In fact, we almost never scan at 90 lines per degree. The file is huge, and it's just way more data than you usually need. We usually do 30, 40, maybe 50. If we're really trying to get a lot of detail, maybe 60 lines per degree. But if you really needed to, you could do up to 90 lines per degree. So very, very dense, very, very accurate. And this is a class 3R laser, so this will work outside. And it also comes in a model 80, which is a class 1 laser. So depending on your needs, you've got two different models there. Now, there's 3 ways to actually run this scanner. There is just pushing the buttons right on the top and telling it to scan. There is connecting through Wi-Fi to either a computer, a tablet, or a smartphone, and basically running it remotely. Or the last way is to tether it. You can tether both power and data right here on the front. So depending on your needs, you can run it any of those different ways. So what we'll do is we'll get set up now, and we'll actually take some scans and talk more about it and show some of the scan data. So for our first scan here, we're going to use this cockpit model that you see here. And this is a great example. We do a lot of cockpits, 3D scan them typically for reverse engineering. And this is a great scanner to go in and get into this tight confined area. So we've set the scanner up on a small short tripod, and we're ready to scan. Now, one thing you'll notice is a lot of little dots or targets. Those are for a different scanner. We're going to leave them on here, but those are retro-reflective targets, so I would expect we won't get a good return there because they're highly reflective and they're going to scatter the light. So this will do pretty good on dark, shiny, most things, but these targets, by their design, are going to refract the light, so we probably won't get a return there. But we're ready to go, and in this case, we're just going to do a 360-degree scan. We're running off a computer here, but as I mentioned, you can use a tablet, you can use a smartphone, or you could tether directly to it. So in the software, you can see we have different settings for the lines per degree we talked about. Getting more technical, you can also get into points per degree. That's basically going the other way, but normally we leave that equal because you want equal data density. So we're going to just go ahead and tell it to do a scan, and off it will go. And again, since we're just doing a 360 by 270, it's going to home itself, and then it'll start scanning. Now, as far as the scanning speed, it will vary with your lines per degree. So the more lines per degree, the longer it's going to take, the larger the file will get. We're set at 24 lines per degree in this case, and since we're in really tight in a kind of closed, confined quarters, we should get really good data density at 24 lines per degree. You typically use those higher numbers when things are a little bit farther apart, or you just want to get as much accuracy as possible. But basically, it's going to rotate around and scan. On the screen here, I get a little preview of what the scanner sees as it's going. It's a little bit weird to look at it first because you're basically looking at this hemispherical scan laid out flat. Also, the scanner's really only turning 180 degrees because it's scanning all the way around this way, so it's seeing this way and behind it in each one of those passes. So you can watch this as it goes along. Typically, while this is scanning, we're working on the computer and doing some other things. This is a single scan, but most of the time we're doing multiple scans and aligning them. Now, we'll get into that later, how that alignment process works and different methods of doing that. Because it is line of sight. Typically, anything that blocks the scanner can't see it, you're not going to collect data. So if things are in the way, or you're angled up or down, you're going to have to take multiple scans. So typically, we take scans low, maybe take scans high, to the left, to the right, and then put all those scans together and merge them. And again, we'll get to that. But it's basically going to rotate around and collect the data, and then when we're done, we would move it and go on. And again, while it's scanning, it's line of sight. You wouldn't want anybody walking in front of it, putting their hand in front of it. That's going to block it. Also, things can't be moving while it's scanning. The scanner, the base of it has to be still. The object has to be still, otherwise you're going to get bad data. But if you look closely, you can actually see the line projected as a line, but as we talked about, it's spinning around doing one point at a time. But it's happening so fast, you literally can see that line moving around and picking up that 3D shape. So depending on, again, your lines per degree will dictate how long this takes. It could be about a minute or so, or it could be a few minutes if you're really cranking up that lines per degree, because it's got to move slower to collect that data. And then once it's done, it'll just go back home, and you'll see here on the screen that the scan is done. And then we could move it to another spot and take our next scan and continue on.
So now if we look at the 3D scan data, you can just see the quality of the data. You can see the gauges, you can see the buttons, you can see a really high level of detail inside the cockpit here. And this data can then be used for downstream applications for things like creating CAD models or reverse engineering or doing inspection or even just going in and taking some manual measurements. So once you've created the scan, this is all possible. Now, if we were to go on and scan the entire cockpit, you can see what it looks like on the outside and then coming around here to the inside and doing a full scan. And what we're going to do next is show the process of taking multiple scans and putting that data all together. All right, so next up, we're going to show doing multiple scans and aligning the scan data. And there's a few different methods to do that. In this example, we're going to use spheres to align the data. And spheres, no matter which direction you scan a sphere from, it has the same center point. And as long as you have at least 3 spheres in each scan, you'll be able to align all of those scans by those center points of those spheres. Now, the reason we're using spheres in this example is this part, it's part of a pump. It's a diffuser. It's pretty cylindrical in shape. So as we move around, there's just not a lot of distinct characteristics to this. So by having the spheres there, we ensure that we're locking the data down as we move around. And we'll probably take 4, 5, 6 scans, basically setting it up. We're using a tripod with a gear head so we can kind of lean it over. We'll take a scan, and then we'll move the scanner and take another scan. So we'll probably take 4 or 5 scans around the pump, maybe a couple from the top aiming down inside to try to get as much data inside. And then we'll use a crane to lean the pump over because it is quite heavy, leaving those spheres on the top, and we'll get a few more scans to get the bottom side. And then we're going to show you how we can put all that scan data together. Now, one really nice feature in the software that comes with this scanner is the ability to do a preview and then window into an area to do the scanning, because the preview can be very quick. We can do a very low lines per degree, get a preview like you see here, and then we window into the area or areas that we want to go back and scan at a higher lines per degree. So that allows us to not have to do a 360 by 270 degree scan at 40, 50, 60, 70 lines per degree, because that would take a long time. We do a quick preview, we window in the area we want, and then it'll automatically go back and just scan that area. Okay, so now let's actually take a look at the scan data. So what you see here is a single scan, and what the scanner outputs is a point cloud. What does that mean? Well, basically, as we talked about, the laser goes out, hits an object, gets a return, and sends that back to the scanner. So it's basically recording that XYZ coordinate or that point in space. And as we talked about, it's doing up to 208,000 of those points per second. So this is what a single scan looks like. And again, it's line of sight, so you can see we were about in this location. You can see where the bottom of the scanner was cut off here by that 270 degrees. But that's essentially what a single scan would look like. Now, if you zoom in, and it may be hard to see on the screen here, but it's just little tiny rows of points. And again, that is dictated by our lines per degree and our points per degree. But you get an idea. You can kind of make out the shape of the part, and you can see the density of the points. Now, again, as I back out, the points kind of all run together, and it looks, looks more like a polygon mesh, but it's not. It's actually just points. Now, we need to align all these scans, and we talked about having these spheres to do that. And depending on what software you use, this can be fairly automatic. The scanner automatically finds the center of these spheres and outputs in the center points in a file. And then depending on what software you're using, products like Geomagic and Polyworks have tools in there that will automatically find those center points in each scan and align that data. So as you load that data in, each scan will come in and automatically align as long as there are three center points in each scan that align up with the other scans. Okay, so you can see here we've got about 8 scans now that go all the way around the part, and each one's a different color. And you can see you get a nice alignment. When you see the data kind of bleeding through, the color bleeding through, that shows you've got a good alignment. And now you're going to get a little bit of scatter data. That's typical. But what we want to do is get all this data aligned and then merge it. And what you'll end up with once you merge it is you will end up with a polygon mesh like you see here. And then this becomes triangles instead of points. Now, this process will take a few minutes. We already did this ahead of time, but you get an idea of what that scan data will look like once you've done merging it. So you can see very high quality data from this scanner. So besides using spheres to align the data, you can also just do geometry-based alignments. Now, to do this, you just need to take overlapping scans, and those can be done on the tripod. They can be done low to the ground. Many times we use a jib arm so we can actually hang the scanner upside down and use it on, in this example, a vehicle exterior or even a vehicle interior. Many times it's nice to use a jib arm. But you're going to go around and get all these overlapping scans. And if you're not using spheres, then you'll do geometry-based alignments. And you may not use spheres for a few different reasons. Sometimes you're in tight areas and it just doesn't make sense. Other times you can't put these spheres on the object for various reasons. But the geometry-based alignment will allow you still to align the data. So we have a couple scans here from the vehicle, and you can see they're not lined up. They've got good overlap, but they're in different coordinate systems. The scanner, wherever you set the scanner, the center of the scanner is 0, 0, 0, and then it goes from there. So what we're going to do for geometry-based alignment is simply go in and tell it we're going to align between two scans, pick one and then pick the other. And then basically the easiest thing to do is get them in a similar view. And then we're just going to pick some points that are fairly close. They don't have to be exact, but fairly close. And as we select these, they'll start to kind of do a basic alignment, and then we hit OK, and it will then line them up. So now you can look, you've got good overlap, and then you would just continue to do this all the way around the vehicle until you have all your scans lined up. But that is geometry-based alignments.
So this wraps up our video on the Surphaser 75 HSX 3D scanner. And again, this is a very unique scanner in its ability to get into very tight spaces and get very accurate and very detailed scan data. So either getting into tight spaces or scanning, fairly large parts, this is a great scanner. The data quality and the accuracy allows you to do reverse engineering and inspection and metrology applications all in one scanner. Being small, battery powered, and remotely controlled really lets you take it about anywhere and scan a lot of different things. You can mount it on the tripod, you can put it on the ground, you can hang it upside down or on a jib arm and really do a lot of different things with it. So this is a very unique scanner that allows you, again, to get really high density, good data quality, high accuracy in a portable hemispherical 3D scanner.